When you think about protecting your electrical system, you probably think about things like surge protectors, right? Circuit breakers. Well, what if I told you the most relentless dangers aren't even electrical? Today, we're diving into how the physical world itself, the environment right outside the box, can be the single biggest threat to keeping your electrical panels safe, reliable, and efficient.
Just think about that for a second. The very air, the temperature, the moisture in it, these are constant 24/7 forces working on your system. This isn't about some one-off event like a lightning strike. Nope, this is a continuous battle against the elements. And if you want to win that battle, you've got to understand what you're up against. So we're going to break down the 5 heavy hitters, the key environmental challenges every single electrical panel faces. We've got temperature, water and humidity, dust, space, and finally vibrations. Let's kick things off with the one we can all feel but maybe don't fully appreciate.
First up, temperature. And this is a perfect example of a Goldilocks problem. It can't be too hot, and it can't be too cold. It has to be just right. It's a delicate balancing act, because swinging too far in either direction can be absolutely devastating.
Okay, so if it gets too hot, components wear out way faster, and the whole system is more likely to fail. Too cold, and you get condensation, basically water forming inside the panel. And we all know water and electricity do not mix. That's the fast track to short circuits. But here's the real kicker. It's not just one heat wave or a single cold snap. It's the constant and visible stress of temperature swinging back and forth that really wears a system down over time. So stability isn't just a nice to have, it's the whole ballgame.
So how do we get that stability? Well, the answer is proactive climate control. We're talking about ventilation, cooling systems, maybe even heaters if you're in a really cold spot. But you can't just set it and forget it. You need to be constantly monitoring the temperature inside that panel and have alerts set up so you know the second things start to go sideways. It's about staying one step ahead. And that leads us perfectly into our next big threat, water and humidity. We call them the silent killers for a reason. Moisture doesn't announce itself with a big bang. It just quietly gets to work, corroding connections, breaking down insulation, and basically setting the stage for a total disaster down the road.
So your first line of defense is the panel's enclosure itself. You've probably seen a rating like IP54 on equipment before. That's not just some random string of letters and numbers. IP stands for ingress protection. The first number, the 5, tells you it's protected from most dust. The second number, the 4, means it can handle water splashing on it from any direction. An IP54 rating is a really solid starting point.
And here we are back to temperature again. See how it's all connected? The magic number you want to aim for inside the panel is right around 35 degrees Celsius. Why that specific number? Because keeping the internal temperature consistently above the dew point, that's the point where air gets saturated and starts forming condensation, is the single best way to keep things dry. It's just using simple physics to your advantage. So, let's recap the game plan for staying dry. 1. Start with an IP54 rated panel. 2. Make sure your vents are covered properly, especially if you're in an area with water jets. And 3. Keep that internal temperature steady at around 35 degrees Celsius. It's a simple 3-part defense against moisture. All right, next on the list is dust. It seems pretty harmless, right? But in an industrial setting, it's a total menace. Dust gets into absolutely everything, clogging up air intakes, coating sensitive parts, and basically acting like a thick, insulating blanket that traps heat and suffocates your system. The solution here is all about good housekeeping, really. You install filter fan units to stop the dust from getting in. But, and this is the part people forget, you have to periodically clean or replace those filters. A clogged filter is almost as useless as no filter at all. Add in some regular cleaning inside the panel itself, and you'll keep that dust from ever becoming a real problem. Okay, let's tackle our last 2 threats together, space and vibrations. They both come from the physical world around the panel, but they attack in very different ways. You could call them the physical foes, challenging the panel's very structure and integrity. The problem with not having enough space is really a 2-for-1 deal. First, you might not have enough room for air to circulate, which brings us right back to our old enemy, overheating. And second, if you cram things in too tightly, you could be violating safety codes. The solution is just smart design. Using compact, modular panels helps a lot. And if you're in a real tight spot where you can't get airflow around the panel, a roof exhaust unit can be a total lifesaver.
And then there's vibrations. If your panel is anywhere near heavy machinery, this is a huge one. That constant shaking can literally rattle electrical connections loose over time. This can cause all sorts of weird intermittent problems or even a complete failure. The fix is mechanical. You use anti-vibration mounts to isolate the panel from the shaking and flexible cables that can absorb that movement without putting stress on the connections. So, as we look back at all these threats, temperature, moisture, dust, space, vibrations, a really clear theme starts to pop out, doesn't it? The best solution isn't about reacting to problems after they happen. It's all about proactive planning. Your design is your defense.
And honestly, this quote from the source material just says it all perfectly. When you think about and solve for these environmental issues right from the get-go in the design phase, you're not just installing a box of electronics. You're actually creating a protected, ideal ecosystem for it to live in. And that is what guarantees your system will last and run efficiently for years to come.
So, the question I want to leave you with is this. Think about your own system or the next one you're planning. Is it in a hot factory? A damp basement? Is it right next to a giant machine that shakes the whole floor? What's its biggest environmental enemy? And more importantly, is your design ready for the fight?